Hey y'all, it's Sarah. I'm back with another video in my Calculus 1 series. We're still in pre-calculus review material. Today we're going to be talking about polynomials and rational functions. So first of all, linear functions. So this should be pretty familiar. These are just functions that when you graph them, they look like a line. So they can be written in the form y equals mx plus b or f of x equals mx plus b, where m is going to be our slope, and then b is going to be our y-intercept. And so when we graph these, they're always going to look like a straight line. So let's look at an example here. So here, our y-intercept is -1, and then our slope is 2. So rise over run, and we're going to have something that looks like this, right? So that is going to be our graph. So as you can see, it's a straight line. Now, linear functions are actually a special case of something called polynomials. It's a type of function that can be written in this form that might look complicated now, but I promise it's simpler once you see examples. So basically, these are going to be functions where we have some combination where we take different powers of x, we multiply them by different coefficients, and we add them together or subtract them together if the coefficients are negative. So we could have, like, you know, the line we just drew would be a polynomial. We could have something with an x squared in there. And we can go as high as we want, right? 5x to the 7th, right? So all of those would be considered polynomials. The degree of a polynomial is the highest power of x that's included in the polynomial. So in our first function here, there's just x to the first power, so our degree is 1. In our second function, there's an x squared, so the degree is 2. And then in the third function, we have x to the 7th, so our degree is 7. So linear functions are going to be first degree polynomials. Now we have words for other types of polynomials based on their degree. So a quadratic function is going to be a polynomial of degree 2, and so it's going to be written in this form here. And basically, when you think of quadratics, think parabolas, right? So you're going to have something that looks like that, or something that looks like that, and then the width of the parabola, as well as the direction in which it opens, and its positioning on the graph, are all going to be determined by the coefficients. And then there are lots of different names for higher degree polynomials, but we're just going to stop at cubic. So a cubic function is a polynomial of degree 3. It can be written in this form, and when you're looking at cubics, you're typically going to have something like this. There's like a bounce to it, right? Or it could just kind of stop in the middle. And it could go either way, but that's generally what a cubic is going to look like. And then finally, we have rational functions. So these are a quotient of polynomials. Basically, what we do is we take two polynomials and we just divide them. So let's say we have a linear one on top and a cubic one on bottom, right? So this would be an example of a rational function. Now, the behavior of the graph of a rational function is really going to depend on the polynomials themselves that are in the numerator and the denominator and the interactions between them. We can have things cancel out and things like that. We'll get more into that later on in the series when we talk about continuity and limits, but we'll just leave it there for now. Yeah, if you enjoyed this video, please leave a like, and if you want to see more content like this, please subscribe.